All right, so we've looked at matter. Let's look at energy now. With energy, which is not matter as we know, it's the stuff that does not have mass or volume. We can kind of classify energy in two ways. We can classify it as kinetic energy or potential energy. Kinetic energy is related to motion, so something that's extensively studied in physics, or the subdivision of chemistry called physical chemistry. Really deals with a lot more about kinetic energy. We'll talk about kinetic energy when we talk about gases in chapter 10. But kinetic energy is associated with motion. And while we have equations for it, which I'll give you, we're not really going to use these equations. For kinetic energy, we're looking at 1/2 mv squared. So an object in motion will have a mass and a velocity. That's a 2, by the way. That's a very ugly 2. Let's redraw that. And so any object in motion will have kinetic energy associated with its velocity, its speed, and its mass. And so that's kind of where we're going to leave kinetic energy until we talk about gas molecules later on. We're going to see that most of the energy we're going to talk about will be potential energy. And so potential energy comes in many flavors, unlike kinetic energy, which is really all about motion. For what we deal with, we have often gravitational potential energy. For example, if I were to get up on this desk, I would have higher energy than I did down here in my chair. And I could release that energy by jumping off, transforming that energy into kinetic energy. But I'm a little bit bigger than molecules and atoms. And so I will probably be pretty affected by gravity. Atoms and molecules are too small to really have gravity as one of their main considerations for energy. So really with potential energy in terms of chemistry stuff, we deal with electrostatics. And that's how charges interact together. And so we're going to see many of the forces between molecules depend on charge. So positives and negatives attract each other, positive and positive repel, negative repel. So electrostatic energy will be another main form of potential energy for us. And then we have what's generally called chemical energy, which is energy stored within chemical bonds. And that's an interesting one. Let's see, let's do orange here. So that's energy that's stored within bonds. And something that I'll give you a preview of now is that breaking bonds, let's use a different color. I don't like this orange anymore. We'll use green. Breaking bonds will always it always takes energy. So we have to put energy in to break bonds. And we'll learn all about what types of chemical bonds we're going to be dealing with. So breaking bonds always takes energy to happen, and making bonds releases energy. And that's really what the core of chapter 5 will be on. We'll look at electrostatic energy, but we'll look mostly at chemical energy. How much energy is it going to take for us to break some bonds, and how much energy is released when we make bonds in a chemical reaction? That's thermochemistry, and that's chapter 5 for us. So we'll really focus on energy at that point. And again, the kinetic energy we'll focus on in chapter 10 when we study gases. And so it kind of, we should summarize this section with a few more definitions. We can actually define energy, although we kind of already know, we have an idea of what energy is, we can formally define it. It's the capacity to do work or heat something. And work and heat are also very important terms for us. Work relates to making things move. If we want to talk about work, work in physics is defined as force times distance. Again, this is not something we're going to need here, although we will work on this a little bit. Oh, did I just say work? Shame on me. No puns allowed. We will talk about work in Chapter 5 in thermochemistry, and we'll have a different equation there. So this is, again, not an equation we're going to work with. On the other hand, energy can also be used to heat something, and heating something is increasing its temperature. And we will see that temperature is very closely associated with kinetic energy. So both of these still deal with kinetics and kinetic energy. And we're going to see that very often we'll be taking the energy that's stored within chemical bonds, which is potential energy, and we'll be transforming it into kinetic energy in ways such as work or heat. And enough of energy, so that's our intro to energy. We'll talk about this, as I've mentioned many times now, in Chapter 5. So we're going to kind of leave it alone for now and continue on with our introductions to other things. We'll talk about how we do measurements in our next video.